Here we're starting again. We can factor 2x squared from all three terms. Brian, what remains right here? When we factor out 2x squared, we get x to the sixth power minus, this would have to be 6x to the fourth. Am I correct there? No. 6x to the third, right? And this would have to be just 8. And now, when you see this, hopefully you realize this is just what I called, Haley, do you remember me saying quadratic style? So we can use the big X. And then this would be like A is 1 and C is 8. So this would be 8 and negative 6. And we're looking for two numbers that multiply to be 8 and add to be negative 6. What two numbers would those be? Negative 2 and negative 4. Now, question. How did I know that this is a quadratic style? Because the power here is what? Half of the power 6. Remember that idea? So if this power in the middle is half of the larger power, you can use a quadratic to factor it. And so when you do that, this would be 2x squared times x minus 2 and x, minus 4. The thing is that it's not just x. This term times this term has to be x to the sixth. And when you add up the results, you have to get negative 6x cubed. So that means each one of these has to be x cubed. Can you raise your hand if you got this? Okay. Now, you might think that this is a difference of cubes because it's x cubed, but this is actually not a difference of cubes because 2 is not a perfect cube. So this is actually completely factored. Let's look at number 4. Number 4, we look here and we always want to think, is there a common monomial that we can factor out? What can we factor out of both of these? It was 6z squared, and then what remains is z cubed minus 125. Can you raise your hand if that makes sense? Okay, now, when you have that, you want to try to finish a factorization if you can. In other words, they call it completely factored. What rule can we apply right here? What's the rule that you can still apply here? Or factoring strategy? Does anybody over here remember? This is a difference of, yes. So I'm going to write the next step. It's going to be, actually, first, how do I teach this? I say, identify, let me use a different color, identify what got cubed. Identify what got cubed. So what got cubed here was z. What got cubed right here? 5. And now you can write your final factorization using difference of cubes. This will be 6z squared, and this will be, when it's minus, I think it's z minus 5, because it's like a minus b, and then this is a squared, so this will be z squared, and then this will be plus, good, George, ab is going to be 10z, because it's 5 times, it's 5, it's ab, it's just ab, it's just 5z, so 5z. And then this last part will be plus whatever the b is squared, and that will be 25 because 5 squared is 25. And that's completely factored. So you had to realize this was a difference of cubes at the end. This is tricky stuff, and if you're focused, that's good. Rest, you can go. Now, number 5. If you have a negative first and a positive, it's easy if you just switch the order. This is a rule we learned earlier, and it's not really a rule, but a factoring strategy. Does anybody remember what we call this? This is difference of squares, and the way you have to notice it is to realize this is a perfect square, And this is also a perfect square. So what is this what is its square root? What makes 81? 9. What makes 16x to the fourth when you square it? 4x squared, and the negative stays in the middle. Now we can write this as a difference of squares. This will be 9 plus 4x squared, and this will be 9 minus 4x squared. Is everybody cool with what I'm doing? I like our focus for the most part. Now, I want to move this number 6 down because we still have a little bit of ways to go. And I actually want to make a bit of space right here because what's going to happen is that one of these can still be factored. Which one of these, A or B, can still be factored? A is a sum of squares. 9 is a square, and 4x squared is a perfect square. So we cannot factor A. How can we factor B? It's almost ridiculous, but the idea, Ruben, repeats. This is a difference of squares again. So what's going to happen is the first chunk is just going to stay 9 plus 4x squared. But you have to look at this and say, oh, perfect square minus another perfect square. So let's do the work. What would this be? Oh, that's really ruining the video. Cassandra, could you help us? What could I possibly mean by help us? Student speaking? Thank you so much. What is going to go in here, Angel? Denise is going home. Check Schoology for the homework. What squared makes 9? You got to stay with me. It's 3. That's what Oscar's trying to tell you. What squared makes 4x squared? 2x. This is tricky, but try to stay with me. We can factor this second parenthesis. Have a good weekend. We can factor this second parenthesis actually as another difference of squares. So the first parenthesis maintains 9 plus 4x squared because there's no factorization for a sum of squares, but this one factors. What will it be? Stephanie, are you with me? Not necessarily, but I see your focus now. Sebastian, can you tell us? So I did the work. I already did the work. You just have to apply the difference of squares. Tony, can you tell us? 9 was broken into 3 squared, and 4x squared was broken into 2x squared. Haley? Yeah, exactly. 3 plus 2x and 3 minus 2x. And we're just using difference of squares. It's kind of like what you want to see is imagine that this isn't even part of the problem. All I gave you was this. If that's all I gave you, it would be a difference of squares. All right. So I hope we're starting to catch on. Nah? I don't know, Brian. Let's do another one. Check this out. One more. Here, hopefully you see, again, it's a difference of squares. So what goes in this first parenthesis that would get squared? X squared squared is 4. What squared is 16? 4. I should say x squared squared is x to the 4th. Now we can write this as a difference of squares. What's it going to be? X squared minus 4. So we're factoring it, and then the other factor over here, x squared plus 4. We're just using difference of squares. Now, which one of these, A or B, can still be factored? Hopefully you realize A, because it's a difference of squares. So you could factor this one and say, okay, this will be what what is each of these perfect squares? Oh, that's going to be x, and this is going to be 2. This one doesn't factor because it's a sum of squares. And so this would be x minus 2 times x plus 2, and then this would stay the same. And this is now fully factored.